Lesson 2 for the quantifying chemical compounds unit is all about molar masses. Now, the term molar masses should sound familiar to you because we actually already determined molar masses of individual elements, but these are molar masses for compounds. So what we have already learned at this point is that molar mass is a mass in grams of 1 mole of an element, and now we're adding on a new part of the definition, or a compound. So let's say I asked you what's the molar mass of sulfur. What you know about sulfur is that if I had 1 atom of sulfur, you can look on the periodic table and look at the value of sulfur being 32.066 AMU. Notice the unit on this side of the ratio is 1 atom. So if I had 1 teeny tiny, more than microscopic atom of sulfur, then we would use the units AMU, atomic mass units. However, because that is way difficult to work with in a lab, really impossible, we talk in terms of moles. So 1 mole of sulfur, so like this is my little balance and I have sulfur on the balance because it's yellow, is equal to 32.066 grams of sulfur. So that's why the balance reads that, which is also equal to 6.02 times 10 to the 23 atoms of sulfur. So now that we know a lot more about Avogadro's number and the value from the periodic table, really we could just go ahead and associate all 3 of these values as being equal to each other. It just kind of depends on the scenario that we are dealing with. So whenever we're determining the molar mass of a compound, basically what we need to make sure we need to know how to do is, number 1, write a chemical formula. Sometimes I'll give you the formulas, sometimes I won't. If you really struggled with writing formulas, you might want to go back and watch those videos. But if you know how to write formulas, then that's great. Then you're at a good starting point for this section. Now, whenever we determine the formulas, you're basically just going to get the mass of each of the elements in that compound, and then you're going to use the units of grams per mole like we already have been. And these are just units. We can represent grams per moles like grams over moles or G/mole. Either way is fine, but then we're also going to be using it as a ratio. So these are the formal instructions on how to determine the molar mass of a compound. We're going to determine the formula. We are going to use the periodic table. We're going to multiply the masses of each specific element by the number of atoms, and then take the sum, which just means add them all up. But I always like to use the examples to kind of further explain the rules. So let's just look at that. If I ask you to determine the molar mass of sulfur trioxide, you need to write a formula first for sulfur trioxide. This is a molecular compound. It starts with a nonmetal and it has a prefix in it. So there's really not a lot of difficulty in this one. It's just SO3. So if I asked you to determine the molar mass, you get out your periodic table, you find the mass of sulfur. It's 32.066. We are going to then add it to the mass of 3 oxygens. So oxygen times 3. And go ahead and throw that in parentheses just so that you know this is all representing this part of the formula, and you can put that in your calculators. 32.066 plus 15.999 times 3, and we get 80.063. Our proper unit here is grams per mole because this is the mass of 1 mole of sulfur trioxide. Now, your calculators that you use in my classroom are pretty smart. You don't have to use parentheses. You can if it helps you to differentiate one element from another, but you don't have to because it knows about PEMDAS. It knows to multiply the values next to each other before adding on, so you don't really need to do that. I'm going to talk about how many digits to carry out your answers to in just a moment. So 80.063 is the molar mass for sulfur trioxide. We could also take that molar mass and write it as a ratio because we are going to be using them in dimensional analysis problems. So as a ratio, I would write 1 mole of SO3 equals 80.063 grams of sulfur trioxide. So this is how I would write that ratio. Remember, you just separate it by the slash. All right, so I just talked about, I would tell you how we are supposed to carry out our molar masses. So if we're being super proper, remember that the rules for addition and subtraction when it comes to using significant figures is your answer is rounded to the same place value as your least precise measurement. Well, lucky for us, most of the measurements on the periodic table are carried out to the thousandths place. So we'll see that they have this column in common. So we're just going to use this quick rule of thumb. As a general rule, let's just go ahead and round all of our molar masses to the thousandths place. This is the tenths, hundredths, and thousandths place. Even though that won't always be the case, let's just go ahead and use that rule. I know that you're looking at this number 80.063, and you're thinking that it's not very different from 80. If you personally choose to just round it to 80, I'm not going to stop you from doing that. But if you do that, you're going to notice that your answers aren't going to be as close to my values as I'm showing them to you, and you might not figure out, if you're doing something wrong or not because you're taking shortcuts. So I advise you to carry out your values to the thousandths place, just so you can make sure that you're doing everything right, especially to start off with. All right, determine the molar mass of calcium nitrate. I would love for you to hit pause if you think you're ready for it, write a formula, and determine the molar mass. If you need a few hints, here they are. Calcium nitrate is an ionic compound. Feel free to hit pause anytime a light bulb goes off and you know exactly what to do next. So calcium nitrate is an ionic compound. When you have an ionic compound, you must first consider the ions before writing a proper formula. This is the ion for calcium. Nitrate is something on the back of the periodic table, and it looks like this. And when you even out the charges, when you add ions to make sure all your charges cancel out, you have this. After making sure I have all the ions I need, I have 2 positive charges, 2 negative charges, I can write my final formula like so. 1 calcium ion and 2 nitrate ions, and I indicate that by putting a 2 on the outside of the nitrate ion in parentheses. So now that we have a proper formula, then we can write a molar mass. If you want to go ahead and hit pause and try to write a molar mass, or calculate rather a molar mass, that might be a good idea too. So as we determine the molar mass for calcium nitrate, we start off by looking for calcium on the periodic table, not to be confused with carbon, which is just C. Calcium has a mass of 40.078 grams per mole, and you need to then determine the mass of nitrogen. It's 14.007. We also have 2 nitrogens in the formula. So the 2 on the outside of the parentheses indicates there are 2 nitrogen atoms. And that also tells us there are 6 oxygen atoms. So then we're going to take the mass of the oxygen and multiply it by 6. Now, even though we are distributing out the 2 to help us calculate the masses, never distribute out the numbers outside the parentheses for a final formula. Calcium nitrate should look like this and not CaN2O6. So here is our calculation. You can put this into your calculator exactly as you see it. If you want to hit pause to calculate that, you can do so. If not, here is our final answer, and I have this rounded to the thousandths place here. It's not by sig figs, I have it rounded to the thousandths place. Our unit is going to be grams per mole. And if I want to write this as a ratio, like I would use it in a dimensional analysis problem, I am going to separate my ratio by this slash and turn that into a colon, and I would have 1 mole of calcium nitrate equals 164.086 grams of calcium nitrate. Here is the next example. Write a molar mass or calculate a molar mass of iron 3 sulfate. Iron 3 sulfate is an ionic compound, and you need to remember that a Roman numeral is the charge for the cation. So I have iron with a 3+ charge. I have sulfate, something on the back of the periodic table. It's SO4 with a 2- charge, and we want to go ahead and even out our ions here. I noticed that there are 3 positives and 2 negatives, so that means I need to add a little bit of each ion until we can have an even number. Now, if I think really hard, I might remember that the least common factor between 3 and 2 is 6. So really my goal here is to try to make charges, 6 positive charges and 6 negative charges. So I'm going to go ahead and add on a bunch of ions here until I end up with 6 positive charges and 6 negative charges, and I do have that here. So I have 2 iron atoms and I have 3 sulfate ions, and so this is Fe2SO4 3. And now I can write a molar mass or calculate a molar mass out of the iron 3 sulfate. So I have 2 iron atoms in the formula, so there's my iron times 2. I have 3 sulfur atoms in the formula, so there's my sulfur times 3. And I have 12 oxygen atoms, so there's my oxygen times 12. We can go ahead and calculate this into our calculators. You really don't even need parentheses, but if you want to include parentheses, great. There's no harm in doing that. But whether you use parentheses or not, here's your answer you should end up with, 399.88. And I only have that rounded to to the hundredths place. Sorry, I really told you guys to carry that out to the thousandths place, didn't I? I apologize for that inconsistency, but nonetheless, this is the correct value, 399.88, or here I have the value written as a ratio. This is the practice box that is in your note packet. Go ahead and hit pause, and you should practice these out, especially the ones that require you to write a formula. Because what you might notice is that if you're writing formulas incorrectly, you definitely are not going to have a correct molar mass. So hit pause, practice one by one if you want. You can do all of them, but if you're ready to continue to watch. I'm only showing you answers here. So for the first one, I have an answer of 45.948 grams per mole of lithium sulfide. For letter B, I have 96.086 grams per mole of what we would call this ammonium carbonate. Now for letter C, if you didn't try this one on your own, I strongly advise you to hit pause and try it on your own first. Because again, you're going to notice that making sure you have the right formula is going to make all the difference in making sure you can calculate a molar mass. So for magnesium hydroxide, I hope you had a formula of Mg with parentheses of OH and the 2 on the outside of the parentheses, because if you didn't have that, you would not have calculated 58.319 grams per mole. And then finally, copper 2 iodide, I have 317.354 grams per mole of CuI2. If you didn't have the correct formula for copper iodide, like if you thought that 2 was the subscript for copper, you also would have the wrong molar mass. So this is one of the reasons why it was important to know how to write formulas in the last unit.